Hi, my name is Cindy McCutcheon from HSPEXP, and today I'm going to talk to you about the Multi-Simulation Manager tool in HSPEXP+. HSPEXP+ is for HSPF modeling. Multi-Simulation Manager can be used for sensitivity analysis, uncertainty analysis, scenario analysis, calibration, and many other things. To access HSPEXP+, go to the HSPEXP.com webpage and click on Products. From here, locate HSPEXP+ and click on Learn More. Once you get to that page, then you can navigate down to where there's a link to HSPEXP's GitHub site. To access the site, you will have to enter in some user information. Once you're in the site, you can click this HSPEXP link to download the program. If you do end up having any issues with the program, feel free to submit them here in the Issues tab. Once you have the program downloaded, go ahead and create a folder in which to run your analysis. The first analysis we'll look at is the sensitivity analysis. So in your folder, you'll want to put your project UCI and a WDM with the name that matches the UCI for outputs and any other WDMs that are needed to run your UCI. Go ahead and open your UCI and scroll down to the External Targets block. Once you're here, you'll want to make sure that you're outputting whatever parameters you may want to evaluate with your sensitivity analysis. This model runs nutrients, sediment, dissolved oxygen, temperature, and hydrology, and so I make sure to look at a lot of those parameters for the evaluation of the sensitivity of this model. So go ahead and open HSPEXP+ and click the Browse button and navigate to your UCI that you saved in your folder. The years should populate with the years that are in the UCI running, and you can shorten these for testing purposes if you'd like. Click the Multi-Simulation Manager checkbox and then click Start. And this will create a series of files and an output box. The most important file here that it created that we'll need to look at next is this multi-sim spec file.csv. In this multi-sim spec file, this third column will contain the DSNs that you had put in your UCI for your external targets outputs. For parameter adjustments in this default multi-sim spec file, we have the parameter ID, we have the open type or the open sequence type, and this can be purlins, retras, or implins. We have the table name and the parm name, which I'll go into in a little bit detail in a moment, the occurrence number, the multi-factor flag, the operation number, and some optional lower and upper limits. We also have the simulations that we want to run. So you can put as many simulations as you want, and you'll put the parm ID across this top row. I've populated an example multi-sim spec file to speed up our exercise today. The first parameter changes that I made in this multi-sim spec file are purlin parameter changes, and the second parameter changes are retras parameter changes. So the first three that I did are all in this PWAP parm2 table in the UCI, and I was making changes to the LZSN, infilt, and AGWRC parameters. So you can see here that it's the LZSN, infilt, AGWRC, and they're all located in this PWAP parm2 table. For these parameter changes, I made the multiplication factor 1, and I set a lower and upper limit so that our simulations remain realistic. These lower and upper limits are optional. The next parameter changes I made were to the monthly interflow concentrations. There are multiple occurrences of these tables, and so we have to specify which occurrence number that we want to be making changes to. Our first run will be making changes to the first occurrence of the monthly interflow concentration table, and our second run will be making changes to the second interflow concentration table. For the first occurrence of the monthly interflow concentration table, we will be making changes to all of the purlins, but when we get to the second occurrence of that table, we're only going to be making these changes on barren land. Again, we have specified that we will be using the multiplication factor for our parameter adjustments, and I do have an upper and lower limit set for these changes. The last purlin edit that we'll be making is to the IRC in the PWAP Parm 4 table, and we'll only be making that change on forest land. Next, we'll be looking at the reach-res adjustments. The first reach-res parameter adjustment will be in the heat parm table, and we'll be editing the CFS AEX parameter. Again, we'll be using a multiplication factor, and we've set lower and upper limits. Next, we'll be looking at the seed parameter in the phytoparm table, and again, we're using a multiplication factor and looking at making those changes on all reaches. For our adjustments of the reach parameter, we are making adjustments only on reach 2, and the next thing we're doing is the tau CD adjustments, and here we only want to make those changes on the second occurrence of that tau CD in our UCI. So we'll take a quick look at tau CD. So we will only be making changes on the second occurrence of that table, and also we will only be making those changes on reach 1. And again, we've specified the lower and upper limits. In my example file, I did set this delete intermediate UCI files flag to 0, recommending that it does not delete any of the UCI files that it generates as a part of this analysis. The last section of our table is the simulation ID table. So you can run as many different simulations as you want, and you just number those, and then the parm IDs come from the parm IDs up in the first section. Now, if you remember, the majority of our parameter edits will be using the multiplication factor, and there's only one of these multiplication flags that was set to a 0. So when we move down here to our simulation ID table, our first two simulations are going to be adjustments to parameter 1, or LZSN. The first one is going to multiply the current LZSN factor by 0.9, and the second simulation will be multiplying the LZSN by 1.1. When we start editing the infilt, or parameter 2, we'll be making the same changes to that parameter, and the same for parameter 3 and parameter 4. For parameter 5, or the monthly interflow concentration, the second occurrence of that table, we will be doing 4 different simulations and using a few more multiplication factors. Moving on to parameters 6 through 9, we will just be using the multiplication factors of 0.9 and 1.1 to make our parameter adjustments. Finally, when we get down to our tau CD, we set our multiplication factor at 0, and therefore we're just going to be specifying a factor for each simulation that we want to run. So our first factor is set quite low, and our second factor is much, much higher. Now that we have our spec file all set up, go ahead and open HSPEXP Plus again and navigate to the folder in which your UCI is stored. Go ahead and set whichever years you want to run, and then click the checkbox next to Multi-Simulation Manager and click Start. This will begin the run of the Multi-Simulation Manager. You can see as it runs that it's creating UCIs for every run that it does. This run with 22 simulations takes about a minute, so I fast-forwarded to the end of the run. Once everything's finished, go ahead and click OK and look in your outputs for the multisim output.xml. Go ahead and open that in Excel. Once you get your multisim output table open, it's time to review it. The column A has your different simulation IDs listed, and column B has every DSN or parameter that you wanted to output. Columns C through AI have different statistics for those parameters. If you would like to use the Multi-Simulation Manager for an uncertainty analysis instead of a sensitivity analysis, it's a very similar process. What you'd want to do is generate random multipliers using some predefined distribution in any software, such as Excel, R, or MATLAB. And you can run as many simulations as you need to with your randomly generated multipliers. Hopefully this exercise was helpful for you. Thanks!